Number 54, extended response question. A manufacturer produces 3 different sizes of cube-shaped stacking bins with edge lengths as shown. Unique thing, obviously, about a cube is that all sides are equal. So in general, if I had a cube with side length of S, a length, a width, and a height of S, to find the volume of any rectangular prism, we take length times width times height. So in this case, it'd be S times S times S, or S to the 3rd power. So a shortcut for finding the volume of any cube is the side length cubed. So if we look at bin A, we're supposed to find the volume here for part A. Find the volume of that bin. We'll take the side length cubed. 6 cubed is 216, and we measure in cubic inches. Again, it's like how many little cubes would fit inside this bigger cube. We'd have 216 little cube inches would fit in there. Bin B, we'll take volume equals side length cubed, so 12 times 12 times 12, which is 1,728 cubic inches. And if we look at bin C, the volume is going to be 18 to the 3rd power. 18 cubed, 18 times 18 times 18, or if you use the power button on your calculator, 18 cubed is 5,832 cubic inches. So there's part A. Part B, we're supposed to find out how many times greater is the edge length of bin B than the edge length of bin A. So the first part of that question, well, the edge length 12, how many times bigger is that than bin A? Well, it'd be 2 times. How many times greater is the volume of bin B, though, than the volume of bin A? So the quick response would be to say that, well, this is twice as big. But if you look, 216 times 2 is 512, which is a lot smaller than 1,728. If we take 1,728 and we divide it by 216, so if I want to figure out how many times bigger, I'll take the larger, divide by the smaller, 1728, divide by 216. We actually end up getting 8. So the bin, even though side length is double, the bin is actually 8 times larger. Now it says in part C, answer the questions in part B for bin A and C. Okay, well, let's now do A and C. So we're looking at a side length of 6 compared to a side length of 18. So the first part of the question, the side length is 3 times bigger. 18 is 3 times 6. As far as the volumes go, if we take the volume of the big one, 5832, and we divide by the smaller one, which is 216, we end up getting 5832 divided by 216. We're looking at 27 times bigger. So the side is 3 times bigger, but it actually ends up being 27 times the actual volume. Now let's finish this off and look at part D. It says challenge. Explain how multiplying the edge length of a cube by a number n affects the volume of the cube. Let's look and see what we have. So we multiply the edge length by n. How does that affect the volume? Make a little table. Well, when we doubled the edge length in B, the volume got bigger by 8. When we tripled the edge length in C, the volume got bigger by 27. Now that's not a whole lot of data to work with, but we might recognize that if we took 2 to the 3rd power, it equals 8. If we took 3 to the 3rd power, it equals 27. In general, if we multiply an edge length by n, the volume is going to get bigger by a factor of n cubed.